great.
yeah, sure.
Just
Yeah.
debating the topic, so you can go ahead with and start class. Yeah, thanks.
Yeah, no problem. Yeah. Yeah,
Okay.
the thing, the question you have asked is correct. So the thing is, like, of course, we should definitely, you should have the different information, different services. As you said, yes, you're dealing with, right? So it's
Mm-hmm.
good that if you know the different other deployment path, in case if you are into deployment, ECR, ECS, in EKS, which is the AWS services, you can concentrate on this also. If you're okay, no, then you can directly enter into this Kubernetes. But before Kubernetes, there is something also to know why Kubernetes, because Dockerization, Docker is complete. Sorry, yeah, Docker completely rely on Kubernetes. So how Kubernetes works? Before that, why Kubernetes? To know that, we should also know, like, Docker. So
Mm-hmm.
once we know Docker only, we understand this Kubernetes, right? So
Yeah.
I will tell you that in the introduction part. But for now in this class, I will only tell Kubernetes. Next class, I will tell what is Docker also and why we are studying. Just the intro part of Docker, I'll tell you. Then we can enter
Mm-hmm.
into the Kubernetes hands-on. Okay. So
Mm-hmm.
today I will also tell you what are the installation you have to keep it ready for us for next class. So you can keep it ready. I have kept everything ready for you, like step by step, everything I have given. You can do that, and next week onwards, you can work on the practical part.
Mm-hmm.
And in our day to
Sorry,
day, yes, yeah,
sorry to interrupt. You saying something about Docker, right? Do you know what I saying? Like, I need to learn how to deploy in a Docker deployment, then Kubernetes.
hmm.
That's kind of the things why I need to. So, if I need to do another course or pay extra, so I don't know whether what's the best path I need to choose. I'm talking to you. Like, if I need to start a Docker class, or is it covering?
Yeah.
Are you covering just covering along with this, or I just want to? I have a WAR file. I need to deploy in a Docker scripts. I know the basic kind of things. I know. I heard about the some scripting for the Docker
Hmm.
files. So I just need to the
Hmm.
full process after the getting WAR file. How to make a Docker, how to make a Kubernetes deployment. That's the main thing. So if I need to learn, if I need to take any other course or anything, let me know. Like I can go to the proper path. I don't like.
Yeah. See, okay, that's what I'm saying. Again, it's up to your interest. If you want to take a proper DevOps course where you will be learning all the services of DevOps, and then there also you have the Docker. No, you don't want, because this course is completely on Kubernetes for me. It's what they have given. Right, the syllabus also I'll let you know. So those are the things which I'll be discussing here. So in our syllabus there's no Docker. But why I am telling you that, I'll tell you the intro part, because it will be helpful for you and for me also to understand, so that
Yeah.
there's no confusion for you why I'm telling you this, right?
Okay.
So
Okay. Okay. Great.
I want to, yeah. So that's the reason I want to tell that intro part that I'm saying. But to your question again, if you want to take a course, then you can definitely talk with Chandran, where he can guide you better. Like if you're
Mm-hmm.
interested, like let's say I'm giving two options. Let's say if you want only Docker, then go only with Docker. So if you want the whole DevOps course, then you have different options. Here in DevOps course, what all things you learn is you learn Linux, okay? Then you learn AWS. You also learn
Mm-hmm.
DevOps. In DevOps, we have five tools like Git, GitHub, Jenkins, Ansible, and then Docker and Kubernetes, right? Where not completely depth what we are studying in Kubernetes, that much we will study, because that is, we have a limitation of for everything, syllabus, whatever is there, no, that we will cover in DevOps, okay? But
Okay.
if you want one particular specific specialization, you can go with that also. And with the DevOps course, we will also give an add-on of Python. I think Python, I'm not sure, but Terraform you have. Terraform is an add-on for you. Add-on in the sense you don't need to pay for Terraform. It's free for you. So like that.
Mm-hmm.
So if you take DevOps course, it's like that. So in like these
Okay.
options we have. So you can check. Yeah.
Yeah. DevOps includes Docker. What all things include?
First it so example, let's say you have taken DevOps, okay?
Yeah. Yeah.
AWS DevOps, okay? As you're
Mm-hmm.
working on AWS, so I suggest you to take AWS itself, okay, rather than other
Mm-hmm.
services like cloud or GCP or Azure, right? So take AWS, and
Mm-hmm.
then with first you will learn Linux, okay? Then you will
Yeah.
learn about AWS, and then you will learn about DevOps. In DevOps, you will study five tools. That is Git and GitHub, Jenkins,
Mm-hmm.
then
Mm-hmm.
Ansible, then Docker, then Kubernetes. Okay. So
Okay.
all five to six, I guess, five to six, all this will go series wise. Okay. Then
Mm-hmm.
Terraform is an add-on to you,
Yeah.
whoever has taken the course of AWS. So
Yeah. That's
it
not
will be
under.
like that. Hmm.
That's clear now. That's clear now. Yeah. So maybe I will
Huh.
talk to you after this close course. Maybe I will talk to Chandran or so you will be taking the whole this class, right?
You can ask Chandran, like the trainer, whatever, you can suggest him. Like if you
Okay.
want my
Okay.
class, then you can tell him, then he will be giving the my batch in that way.
Okay. Okay. That's great. Okay. No worries.
Yeah.
Go ahead. Yeah. Sorry for
Yeah.
interrupting you.
No, no problem. First date will go like this for me. Okay, chill.
Yeah. Yeah. Yeah.
Okay. Yeah. Introduction to Kubernetes. Okay. As I said, like Docker, I'll think, but in the next class. But yeah, I'll say. Okay.
Yeah.
Okay. First and foremost thing, it is an open source container. It is called as orchestration. Why it is called orchestration? Because it is somebody who is mastering the um Docker. Okay. 1 minute, I'll give you the diagram here where you have a better understand. Uh, okay. Okay, fine. This is very bad picture, I know. But still, I have to do. See, we have some Docker, and I know the picture is very bad, but please adjust. I'll show you the
Mhm.
image also on the Google. Okay.
Mhm.
This is all about Docker. I have like you have if you have seen the Docker, then you might have know what how it looks like. Okay. All these are containers. Okay.
Mhm.
So somebody like that many containers. All this is containers where Docker look after. For this,
Mhm.
somebody to manage, there should be somebody who should master this. Master in the sense team lead. Let's say you have a five members of team, then that's fine. Team lead is not required. But if you have 50 members of team, then of course there should be somebody who can lead them and tell them and give their assign them work, task, and whatever they are doing, monitoring things should happen. If somebody should be there to guide and take the suggestion, give the suggestion, many more things, right? So the same thing here also, when there is multiple containers, somebody is mastering. Actually, for Docker, it is called as you know, or containerization. It is known as containerization tool. Docker name is itself. It's now called as containerization. For this containers, there is somebody who is mastering this, who will handle this. So Kubernetes is master of this container. That's why it is called as orchestration. Orchestration in the sense, so I know you know this, but still I want to show some image. Orchestration, orchestra. You can see this man, right? So who is guiding you, right? He will be
Mhm.
holding some stick, and then the music go in that way. If you say up, it will go high, come down. Like they have their own method to do, right? The same thing
Yeah.
here also. Our Kubernetes is telling this to our Docker, stating you
Mhm.
have to do the work in this way only. Okay, that is why the
Yeah.
name has come orchestration. The name
Yeah.
for Kubernetes it has come orchestration. It is an open source. Again, here we no need to pay for Kubernetes. Kubernetes is not paid version. Again, but if you are working this Kubernetes on your AWS EC2 instance, then of course we require a larger machine which will charge us. So for practice purpose, I will not go with that. Okay, we will do something which is available locally. Exact steps you can follow in the remote when you're working in your company. Okay. So,
Mhm.
yeah, so it is called as container, which is called as orchestration. System, it was developed actually in the beginning by Google, okay, but now it is maintained by CNCF, that is Cloud Native Computing Foundation. It is maintained by them. First of all,
Mhm.
why the Kubernetes has come? First, because of deployment. Deployment is like automatically deploy application across nodes. So we no need to go and do it manually. It is done for you. if you have set up a proper replicas on that. Okay, and how to do we will see. First concept is for deployment. Second is for scaling. Let's say you want, you don't know when your containers require scale up and scale down. So that process is looked after by this Kubernetes, that is scaling. So whenever there is high requirement, it will go up. Then whenever there is down, then it will come down. That is the work of scaling. The one is load balancing. Load balancing in the sense it will distribute the traffic. If you have, again, you might also be aware of this, like Elastic Load Balancer, which is an AWS service, which will distribute the traffic. The same thing here also. It is done across the pods. So again, what is pods and all, I will tell. Not to worry about it. Okay, but yeah, I think I'll tell you about it. Okay, it looks after the traffic in the pods across all the pods. Okay, and
Yeah.
self-healing. Self-healing in the sense it will detect the failed containers. Let's say I'll show you Docker. So here we have Docker. So on this container, let's say this is the
Yeah.
container.
Yeah.
This container, in case if it is got failed, okay, that time if because there's an complete application which is running on this container. If this, as I said, not to worry, I will completely tell about this you in the next class. But for now, just remember this is a container. In case of it is
Mm-hmm.
it is deleting. Sorry, if something got failed, it is not working, but your application is working on that. If in case if you have not done, then it might affect the end user. So in case if something is happening, uh, Kubernetes detects that and makes sure the next container is ready such that the next next in the sense like the user should not affect it. So the self-healing is possible here in the Kubernetes. So that is the character, it automates that work. Again, for
Okay.
configuration and management, means it manages the secrets and maps. So in the sense like we will see what is config map, but here I just want to tell it also take care of your configuration management completely. In that way it works, and it is also for rolling updates and rollbacks. In the sense, it update the app with zero downtime and revert if needed. Example,
Mm-hmm.
downtime, you don't need downtime in the sense you don't need to, you don't need to, what I can say, you don't need to make your application down, zero downtime in the sense your application is running but still work is done for you, right? So zero downtime. So you no need to always, whenever we do some changes on our AWS services, EC2 instance, we stop, then we perform the task, and then we again restart it. But here it's not like that. Without, even though you are working continuously, your work is done for you. Like you no need to go with zero downtime. So only they are mentioning zero downtime. Means you no need to wait or you no need to stop your application. It will work continuously. In that way, rolling back and updates is possible for you. So yeah, so these are the six main things for Kubernetes. Why Kubernetes has come into picture? Okay. Again, here,
Mm-hmm.
why Kubernetes? The question here is why Kubernetes? Okay. Why Kubernetes in
Mm-hmm.
the sense here it is containers like Docker solve the packages. Okay, why Kubernetes has come? Because Docker, so for this, as I said, Docker, what it is works, I'll tell you. But here for now, remember, Docker is a package of tool. Package in the sense, let's say, as you are working on Java, there are so many, if let's say on Node.js, if you want, and also they are like, Node module is compulsory for you, then only the packages it will work, right? Otherwise, that is a dependency which is required for Java, right? Sorry, not Java. I'm
Mm-hmm.
sorry. Node.js, okay? The modules, whatever you want, right? Node module, right?
Mm-hmm.
The dependencies is
Yeah.
required compulsory. Without dependency, it's not possible and application is not running, right? So the
Mm-hmm.
Docker, let's say the Docker works in that way. It makes sure whatever the dependency is already there in that file, Docker file, then only it is
Mm-hmm.
giving you the image. Image in the sense, application, programming language, anything, Python, MySQL, this is considered as image in the Docker. Okay,
Mm-hmm.
whatever you deploy, everything is considered as Docker image in the Docker. Okay, so Docker solves only the packaging problem and the dependency problem, but it does not solve the problem of scaling. It does not solve the problem of networking. It does not solve the problem of resilience. But Kubernetes does that. Okay, so that's why Kubernetes is ahead of Docker. Of course, Docker solve most of the problem, but which problem Docker will not solve, that problem is solved by the Kubernetes. So every company definitely go with Kubernetes. Wherever you find Docker, the Kubernetes will come into picture. So Kubernetes is mastering the Docker again.
Yeah.
Kubernetes,
So,
yeah.
sorry, this the scaling in the sense, what if there is multiple many users are coming, we need to give more instance, or what's the
Yeah, okay, fine. I'll tell you that. Example, let's say this is one EC2 instance. Okay. One EC2 instance, and let's say it can handle only 100 user load.
okay?
100 users only it can take the load. Okay. But
Mm-hmm.
let's say during festival or any of the cricket season, let's say Hotstar or anything, okay, anything might be there. So that time you don't know how much it might, but you know there's a traffic will be there. Traffic in the sense users will
Mm-hmm.
be increased. The load of the application will increase. So that time what will
Yeah.
happen? You have set actually one instance, that is one application, right? But
Yeah. One
you don't
instance.
know, yeah. So you don't know the traffic how much you require. So, but you can have approximately count. Let's say you say my application should go from two to four, six, we'll say six. Okay. Beyond this, it will not be there. Okay. You give, if let's say you can also give eight also, no problem. Okay. Depends on the scenario, and we will understand, we'll give a maximization also. Okay. So at that period of time, the instances will get increased. Okay. Either in
Mm-hmm.
horizontally or in vertically. I'll tell that. Okay. If the instance is creating in the, let's say one instance, two instance, three instance, it is creating in the horizontal way, that is called as horizontal scaling. Okay. But
Mm-hmm.
let's say I don't want my instance to be created separately. I say, let's say I have my EC2 instance, like yeah, I'll show you if you
To
are,
be
like if you know
in
T3 micro is my instance type. Instance type in the sense machine type. Let's say I have my
machine
phone.
tab.
I say, yeah, how much
Yeah.
is my GB? This is my phone. I
Yeah.
tell this is my
Memory and
GB. This,
everything, right?
yeah, memory type. Yeah. So
Yeah.
like that here also, T3 micro is an instance type. Okay. But
Mm-hmm.
let's say this is a small one, okay? But you want a
Small one.
large
Yeah.
machine. Hmm.
Yeah.
But if you
Understandable. Yeah.
want, if you want a large machine, let's say something called, some large machine you have. I've currently, okay, I'll say T3 nano, which is bigger than micro, okay? So
Mm-hmm.
little bigger, I can say, or something. Okay, let's say I don't remember for now. Okay, if it's there also, I'll tell you. Machine type. Okay, some large machine it is. Let's say this is a large one. Okay, that time you will
Mm-hmm.
say from T3 to nano, you should increase.
Mm-hmm. Yeah.
You should increase your size. Don't
Yeah.
create one more instance, but increase the size. Okay, that will fall
Yeah.
under vertical scaling. This is the scaling. So
Yeah.
this actually on AWS we set up auto scaling. We have a concept of auto scaling. There we do it. Okay, but here in
Mm-hmm.
Kubernetes, Kubernetes does itself. Like here we are not telling for for Kubernetes the size and all. But let's say we will see replicas in the sense creating. Okay, we say from
Mm-hmm.
zero, from one, it should go to 5. Okay. Then the
Mm-hmm.
traffic increase 6. Then traffic increase 7. Okay. We set up a replicas. So whenever
Mm-hmm.
there is a scaling happen, it will reach maximum to 8. Then whenever it is not required, it will come down. So in this
Okay.
way, the scaling will go high and low based on the requirement.
Yeah, sorry to interrupt you. One more second. Like this, all the notes will be recorded, or can I get some kind of notes, or do I need to write it down, or do you have any record? Can you do the recording somewhere? The
Recording the
class.
class is recording. Yeah, it is getting recorded.
Oh, it's already recorded. Okay, that's fine. So
Huh,
I will get to
huh,
I will get all the things. Okay. Okay, fine. That's great.
huh. Hmm.
Yeah. Go
What I
ahead.
was
Go
saying,
ahead.
node you are saying, na? Here we will set up things. When we create it, na? When create a node pod or something, we will set up that. We will say replica, you should go, if there is a traffic, you have to go. We have to do setup when we do work on those things, right? So when we do a deployment in the script only, we should write that. We call it a snippet. Snippet in the sense it will be written in the YAML file. In that YAML only, we will give a we will give a deployment, and we will give a replica stating ki I want this much. My
Mm-hmm.
instance should go to this much whenever there is a traffic. Okay, that based on that, the deployment will is taken care by Kubernetes. That's what the scaling means. Again,
Yeah.
it is only given you like only it is created only and only if there is a requirement. If there is no requirement, then it will not create.
So
Okay.
what happened? Just one more thing. So you saying that the Kubernetes will do the scaling. That scaling. So it will be sending the instruction to the AWS, or there should be
Uh-huh.
some
Yeah, yeah.
places,
Yeah, yeah.
right?
See, if you have connected this to your AWS, that your AWS will look after whichever the platform you have set up, no, like that. Whatever we are doing
Okay.
is on our mini cube. That will happen on our local only.
Okay. Yeah. Okay.
Yeah,
Go ahead.
yeah. Okay. So architect is very important for us. Okay. Before going with architect, I will also tell you few of the terminologies which is important for us to know about the Kubernetes. First, we have something called clusters. Cluster means what? A group of node machine that run containerized application managed by Kubernetes. Means a group of machine. Group of machine means that we call it as node. Again, node is not one common thing in all the thing. What I can say, we have node in Azure. We have node in Jenkins. We have node in different services. Okay, so
Mm-hmm.
not node means not only one single thing. Okay, it might be machine. It might be your EC2 instance. It might be anything. Okay, node is just a common term we say. Okay,
Mm-hmm.
so yeah, in Ansible also we have node. We say worker node. We say master node. Right, so that is a common term used. So don't get confused. Node means this only. Why we have to do? So you don't get confused if the word comes like that. Okay, node means a machine.
Mm-hmm.
Okay, so that's the thing. A group of node machine that run containerized application managed by Kubernetes. So it is a group of machine. Cluster means cluster name itself says a group of machine. Okay, and which is done on containerized application in the sense Docker application. It is telling about. Okay, and of course this is managed by Kubernetes. And we
Mm-hmm.
know that Kubernetes is managing the container. Okay, and group of simple to say in simple term, group of nodes is called as cluster. Okay,
Mm-hmm.
we will
Mm-hmm.
see that again. Node means what? A physical or virtual machine in the cluster that runs application workloads. Might be your any machine which is running a workload. Any machine, your physical, your virtual machine, anything. Okay, but this cluster is inside the this node is inside the cluster. Okay, in the cluster the node is there. Okay, so that will work on the workloads. So first comes node. Okay, node pod, actually pod. Okay, that I'll tell you. Okay, node is inside the cluster. Okay, next comes pod. Pod means the smallest deploy unit in Kubernetes. A pod can run one or more containers. So here it is contain one or more containers. It is saying okay. The pod it is the smallest deploy unit in Kubernetes. So here it is showing pod is something which is the smallest unit in this. Okay, and it is run on one or more containers. Okay, that we will see
Mm-hmm.
in the architect form, and you have a better understanding. And then we have something called as services. Service means expose an application to the network and enables the communication between components. Means here it is something which exposes an application, that is your pod, to the network. Okay, and enables okay, simple. It's like I tell you, like we will connect on the phone or we will connect on the Teams, right? So there's some
Mm-hmm.
platform that we call as Teams is a service for us, both of us, to connect on the call, is it? So that in that
Yeah.
way the service works in the Kubernetes also. Okay. Namespace means a logical separation within cluster to organize and manage resources. Means okay, let's say we have different team, data team, we have DevOps team, we have cloud team, we have full stack developer team, different team, software team, different team we have, right? Each team has their own specification, each team has their own rules and regulation, each team follows different methods, right? To manage
Mm-hmm.
or to maintain that is like, let's say, like for our application. Okay, uh, a different configuration is required. Okay, that is considered
Mm-hmm.
as namespace. Means there's a separation for all the and everything is organized in a proper way. That is called as namespace. Okay, means a logical separation. A separation will be there within a cluster to organize and manage resources. Let's say there's an application one, there's an application two, there's an application three, and these three applications should run in a proper way and it should be organized, right? Let's say we have school at college, we have periods we call, right? Periods in the sense like time sessions we have, right? 145 minutes for this class, that class, and whatever class, right? So each class will
Mm-hmm.
not have the same classes. Let's say if sixth standard has English class, seventh standard also don't have English class. They will have another class, right? The same thing here
Mm-hmm.
also in our cluster. Everything will not follow the same. Everything will follow in different method, but they will follow in that organized way only. Okay. Let's say we have Kubernetes class. We have class from uh, whatever time, 2 hours you have, right? In the 2 hours, not
Mm-hmm.
every day we go with the same topic, right? We go, we have formatted, we have organized our class. Like first day we will study about intro part, second day we will study about setup, then we third day we will study different topic. Might be for storage, might be for monitoring. Another day we will study about security, right? We have organized this way. So that's what the namespace works like. Namespace is something which is organizing everything you for you and giving you how to manage the resources. Okay, that is about namespace. Again comes the deployment. Deployment means very well we know. Okay, manages the
Yeah.
life cycle of pods and then ensures the desired number of pods are always running. Okay, and we
Yeah.
also have some. Huh?
Yeah, got it.
Okay, we have something called replica set. Replica set means ensures the specified numbers of identified parts pods are running at any time. So it is telling you, ensures a specified number of identical pods. See, replica only means the name itself says something which is copy paste. Copy paste in the sense, what is Xerox copy, right? So the same thing yours
Mm-hmm.
also, one pod, two pod, three pod, but three pods are same. They are twins like, or whatever, triplets, whatever we are giving, right? So based on that,
Mm-hmm.
the pods will be divided. Same copy paste. Okay, that's replica set. Here
Mm-hmm.
again, let's say if I said three replicas, then three replicas work in the same way. Okay, that's replica set. Then comes about our next part, that is label. Label means key value pair used to organize and select Kubernetes objects. Okay, label in the sense. Let's say we let's say in the restaurant, okay, we have different departments. If you go with some street kind of street food, we call, not sure how they will be. It will be there in Ireland, but here we have a different section. One part I get only charts. Another section I get only juice. Another section I'll get only tea, coffee. We call it no pizza department. Like that. That is labels here. Okay.
Mm-hmm.
So based on that, here also we will have something called labels in our Kubernetes. Okay. Then we have something called selector. Selector means used to filter match labels for identifying specific pods. Okay. Let's say here I'm saying pizza department, here I'm saying burger department, here I'm saying some department, okay, some proper food department, okay. So selector is somebody who will tell, okay, let's say I have 10 departments. In the 10
Mm-hmm.
departments, I'm telling I want pizza only. Then selector is going and selecting that out and it is giving the output, ki pizza, please come out. Okay. So selector is doing that work. He will select it. Okay. That's what our, it will also match your labels. Let's say I want pods. I want pod number two only to work for my this task. Then it will bring that pod number two only. Okay. I'm giving an example again. Okay. So that's what the
Mm-hmm.
selector does. And selector also says pod number. Pod number two, you should work in this cluster for 40 minutes only. After that, you should go back to your work. Okay. So it will selector is somebody who schedules like, or somebody who selects and says that what you have to do also. That is the work of the selector. And next, we have something called kubelet. Kubelet means agent running on each node that communicates with the control panel and run pods. Means it is somebody who can communicate with the control panel. What is control panel? I'll tell you that. Okay. So it makes sure it is running on each node and it makes sure the communication should happen between the in the control panel. Okay. Control panel is what we will study in the next topic. And
Mm-hmm.
kubectl is the command line. Okay. whatever we are doing for deployment, networking, volume, monitoring, blah blah things, everything. If you want get the output, the command line for this is kubectl. Okay, like kubectl get pods, kubectl. If I only directly go with get pods, get the deployment, it will not give me the output. So command line is the first line for us for to give the um, kubectl is a command line for us. It's like a tool interacting with Kubernetes API server. So kubectl will talk to the Kubernetes servers and it will
Mm-hmm.
give us the output. This is all about kubectl. Now the
Yeah.
actual the part starts. Till now we have understood the part. Okay, let's say if I tell you EC2 instance, then I'm telling sorry yeah, AWS, then I'm telling the services name EC2, IAM, VPC, CloudWatch, blah blah things, right? What
Mm-hmm.
each thing does. I have told till now that. Okay, but now we will actually study the components, how it works. Okay, control panel means master node, something who is working a master, like master node we call. Okay, node components means worker node. Okay, somebody call control panel as master node also. Somebody call node only node as worker node also. Got it? No, master and worker node. In that way, the Kubernetes works. Okay, some it is also called as control panel. It is also called as worker node. The same way here also node is also node in the sense worker node. Okay, it is also called as worker node. Okay, in
Yeah.
control
Oh,
panel,
sorry.
what? Yeah.
I'm thinking maybe my thinking is issue like I'm thinking about only the my applications that have an WAR file. So
Hmm.
I should deploy the WAR file in the node, right? No, that's the
Hmm.
smallest. No, I should write something on the Docker environment to include the run the WAR file. It requires some Tomcat, some other libraries. That should be a
Hmm.
Docker file for that one, and that should be the Docker environment, right? So this node component and all this comes in where I just trying to relate my how this could be that
Yeah, yeah, yeah,
trying
yeah,
to
yeah, yeah. You're repeating.
ah
Your
yeah, you have a
question.
student.
Yeah,
Yeah, yeah,
yeah.
yeah,
We will discuss
yeah.
that.
Okay, fine.
Okay.
Okay, okay, fine,
Don't
fine,
worry.
fine, fine.
Yeah. Yeah, you will have an idea where all these things falls into picture.
Yeah,
The
yeah, fine,
architecture
fine.
is one of the important part to know. Okay.
Yeah, yeah,
Yeah.
sure, sure. Go
So
ahead. You go ahead.
yeah, it is something which manage the cluster and make your global decision about scheduling,
Mm-hmm,
scaling, and overall state. Okay.
mm-hmm,
And it is the components of this is API server, HCD, control manager, and scheduler. These are the part which we will study in the that architecture. Okay. But here
mm-hmm,
it manages the cluster. It is somebody who manages the cluster, it schedules and scaling, and overall state is looked after this control panel, who is a master node. Okay, and worker node is somebody who run actual work. Okay, let's say principal is master. Okay, in the college, but the teachers and the lecturers are the real one who really teaches the student, right? So
mm-hmm,
how the principal teacher will work in the same way here also our master and worker node work like. Okay, principal is somebody who's instructing, who's giving information, who is taking blah blah things you have to do. But teacher is somebody who's working every day for nine. Well, of course, principal also working, but the somebody who works is the teacher, right? The same thing here also we have who, and each one has a mask components which we will study. And kubelets, kubeproxy, and container runtime we have. Now we will study the architecture. Okay, here again. Control panel is the master node responsible for overall custom management, which we discussed. Worker node responsible for running the application and workloads. Okay. Now the real story starts. I'll tell you, and I'll tell you each terms also what does they do. Okay.
mm-hmm,
This is an
mm-hmm.
UI interface. First one. Then we have CLI.
Yeah,
These both works differently. Okay. In the sense,
mm-hmm,
whatever we do, it talks here. Okay. Same thing
yeah,
here also. Let's say this is the first master node component. This is all about worker node. Okay. This is one worker node and this is second worker node. Okay. So let's discuss about the um, master node. Okay. First master node, under master node, what are the components? Okay. First we have API server. Then we have
mm-hmm,
somebody called scheduler. Then somebody we will have control manager, controller manager. Then we have somebody called HCD. Okay. Somebody called ETCD, somebody called HCD also. It's based on the person's pronunciation, but it is the same. Okay.
mm-hmm,
So
mm-hmm.
usually it's called as HCD only. Okay.
Okay.
Now, these are the components of the master and what does each things will do. Okay. That we will see. Okay, I'll tell you, come back to this again. Again, in the worker nodes. Again, in worker nodes, we have this pod. You can see this containers, right? Container 1, container 2, container 3. Okay. Container means in container 1, let's say application 1 is running. On container 2, application 2 is running. On container 3, application 3 is running. Right? All this
Mm-hmm.
container is looked after by pod, right? That's what we
Mm-hmm.
discussed. Pod might have one or two, three containers based on that. Okay. So pod is the one who is looking after this container. Okay. So again, like this, we have the things. Okay. Again, in the container, we have kubelet and we have kubeproxy. Okay. See, we have this container stuff. On container is running on whom? Container is running on the base platform called Docker. When I say this one, right?
Yeah,
See,
yeah, yeah.
this is the
Mm-hmm.
container. This is the container, right? So container
Mm-hmm.
is running on which platform? Container is running on Docker engine. This we call as Docker engine, right? So
Mm-hmm.
on Docker engine, container is running. Where is our container? Where it container is on our what? You can see, no? So this is the architecture. In this Docker means where our container is running. Under inside that we have two things called as kubelet and kubeproxy. Okay, and what does they do? These two do does as that we will see. Okay, in pod one might be container three. In pod two might be only container one. In pod two might might have only one container. Same thing, pod three also might have two containers. Depends how much container you give. Here also when you see on worker node, first we have two containers, three containers, then one container. Okay, depends on different worker node how it is you're giving into it. Okay, but now each one does what? Right? The question comes, each does what? We understood, okay, this is the architecture it does. But what each term does and why we are studying this, right? That is all about
Mm-hmm.
the thing. Okay. So your control panel is a brain of Kubernetes. It maintains the desired state of the cluster. What application are running, their health and scaling is taken care by this. Okay. Out of this, now I'm telling the okay. You can refer. I will share this with you on your mail. You can share with
Yeah,
me your
yeah.
mail ID. Yeah. So this
Mm-hmm.
is the
Mm-hmm.
API server. This term I'm telling now. Okay.
Yeah.
Here, API server means what? It is it is also called as Cube API server also. Okay. So it depends. Again, the entry point for all clusters which communicates, it exposes RESTful APIs and validates requests. It is the central communication hub between all components. So API server is the first who will communicate. Means it is telling my scale is not working. I know a pod is not working. Container is not working. Blah blah things is not working. Something is going wrong. Traffic is high. Whatever things is happening, no, through API server it goes. That is the first term. That's why here, when we see in the architecture master, API is the first one who is sitting here, right? Where the
Mm-hmm.
communications happen from your UI, your kubectl, whatever it will first come here. Okay, see, UI cannot directly talk to this. Everything should pass through kubectl only. Kubectl will tell to this API server this is happening, and whatever things is happening in from here, it is communicated through API server. API server will talk to kubectl, and in kubectl like this. This is a gateway, I can say. So API server is a gateway to talk with all these things. Okay, that's what does it is telling you. It's a first as a communication between all these things. Okay. Then comes your
Mm-hmm.
HCD. Okay. HCD is like where your data is stored. Means a distribute key value stored used to store cluster data configuration. It maintains information about the state, cluster, pods, nodes, secrets, everything. Okay. Again, in to tell in a very simple word, let's say what like data you have, right? Storage, I can say. Information you have. Everything is stored here in the HCD. If you know, so if you're like, I'm not sure you have worked on Linux, if you know, on ETC, we have one folder called
Yeah.
ETC folder. In this
Yes. Yeah.
ETC folder, all the configuration gets stored, right? Whatever
Mm-hmm.
configuration
Yeah.
for
Mm.
Nginx, Apache, the same thing it works like. All the information is stored here in the HCD. All the data is stored
Mm-hmm.
here. That's what the HCD does there. Okay.
Mm-hmm.
Again comes your control manager. Control manager is somebody who 1 minute. Huh. Control manager is somebody who makes sure the desired state matches the actual state. It runs several controllers such as node controller, replica set control. Okay, not to get confused. Yeah, it's make sure, let's say you want four cluster. It makes sure the four clusters should compulsory run. It should match the count. It will not allow the cluster to come down. If one cluster is coming down, it makes sure the another cluster is immediately getting created. So it is for somebody who takes care of this. It manages everything. Okay. Might be it controls control manager, replica set, controller, deployment, many more, etc. option is looked after by this controller manager. It manages everything such that the end user is not getting affected. Okay. Next comes scheduler. Scheduler means it determines which node a new pod should run on each resource. Means it will schedules. It will tell on pod one, uh, on pod one something, it should run for this much minute. Okay, it not only decides what, it will make sure the availability, which pod is free. It makes sure who can tolerate what. It makes sure what rules they have to follow. Okay, that is taken care by the scheduler, and the scheduler is called as Cube scheduler. Okay, again Cube API server. It is called as Cube controller manager also. It is called as Cube scheduler also. Means it determines your availability. It determines your rules. It determines if anything goes wrong or something, and make sure it is running. Okay, and it is take care the new pod should run. Okay, let's say one pod comes down, it makes sure the another pod goes up also. That is the scheduler. Okay, means something related to time. You can just think of it. Okay, again, controller manager. Cloud Control Manager is an optional, means integrates with Kubernetes underlying clouds like your AWS, GCP, Azure. It manages the cloud services. Okay. Again, Cloud Control Manager is it's an optional. Okay. It's not compulsion, it's an optional. So if you integrate this Kubernetes with your cloud, then somebody comes into picture, that is your cloud manager. Okay. So I hope this you got for the cloud things. Sorry, for the Kubernetes side. API server, what does it do? Scheduler, what does it do? Cloud controller, what does it does? And it etcd. Right? Stores data, brings the communication. Schedules the task. Controller manager makes sure the containers and a deployment part and all those things should actually run based on the requirement. It will not allow the things to come down. If it is happening, it immediately replaces with the next one. That is the it manages things to say everything should go perfectly. Right? That is the taken care by this control manager. This all components will fall under Kubernetes master. Okay.
Okay.
This is about the
So yeah.
yeah.
So can you go to that image again? So the first UI CLI, then Kubernetes master. So that's the one component, right? The whole thing.
Hmm.
Kubernetes
Hmm. Hmm. Hmm.
master. That should be a Kubernetes thing. The other one is a Docker environment that will be we are giving instruction to that one, right? That's
Sorry, I didn't get. You said this one, huh?
the
Master,
the
Kubernetes master.
Kubernetes masters and UI. This is a one component, and another one, that worker node and everything is actually
No, no.
worker node is actually in the part of Kubernetes, or that's a Docker kind of environment, right? Or that contain
No, no, no.
no?
Everything is
Okay.
Kubernetes only. No, no. UI is your interface, your application. Might be your application.
Yeah,
Okay. This is a
yeah, yeah.
diagram stating this will connect to this, and then your UI
Yeah,
will
yeah, that's
communicate.
okay.
Okay.
Understand.
That's
Yeah, that's understand.
that this
Um,
all are yeah. This is master. This whole component is the architect of the Kubernetes
oh
system,
yeah,
not
okay,
Docker.
okay, yeah. Okay, okay, okay,
Yeah.
okay. Okay, yeah, I'm not, yeah, I'm getting a little bit, it's not fully understandable. Maybe I will read more and I will talk to you maybe next class. Yeah, yeah.
Yeah, yeah, I do. I understand. No problem. So what I'll do, no, next class I'll help you to with a
Most
diagram.
probably
Yeah,
90%
yeah,
of the 90% I will go with the DevOps thing, so I will understand more and I will,
yeah.
if it's possible, I will go with that option because otherwise it will not be a easy thing for me.
Yeah, yeah,
I'm
That's what.
working on the Linux for last couple of years. There is no issue with the command etc. That kind of things I am working on, but the Docker is completely no known to me. Maybe yeah, that kind of thing. So I will talk to you anyway. Yeah. Okay, go ahead. You go ahead. Yeah.
Yeah. No problem. That's what I know. See. I can say first day Kubernetes. Definitely, it is like that only. But don't worry, we will do it. I'll
Yeah.
make sure I'll
Yeah.
break down things. Okay.
Yeah.
I have
Okay.
short time. I got short time. That's the reason I thought of like I have to give something, so
Yeah.
I'm
If
giving
you
this
want to,
information. Next time I'll
if you
break
want to
down.
stop, yeah. If you want to stop now, if you want to go somewhere, that's fine for me. Yeah. Like.
No, I'll complete only this worker node, then we can stop. Next we can
Oh.
do
Okay. Okay.
next one.
Okay. Okay. That's fine.
Yeah, yeah. Uh, okay. So then comes your a control panel that is. No, sorry, this is done. So I have given this in simple explanation. Don't worry. Next week I will break down this in simpler method with a diagram way I'll tell you with different
Mm-hmm.
explanation. Then you have that idea. Okay.
Mm-hmm.
Okay. Then comes the worker node. Worker node means somebody who takes care of about the kubelet. Okay. Okay. Components of worker node. Sorry. Kubelet means agents that run on every node. It registers the node with the cluster, receives the pod specification API and ensure the containers are running as expected. It's like team lead.
Mm-hmm.
It makes sure what is given instruction that should follow, that should be followed. If that is not followed, it makes sure that should follow. Okay, it's like team lead, I can say in simple terms. Okay, that is the work of the kubelet in the worker node. Okay, and then comes your
Mm-hmm.
proxy. Proxy means handles the network traffic. Your proxy it's somebody, let's say I'm saying HTTP, yes, it should go. Then next time I'm saying, no, you should go to TCP. Then I'm saying UDP, you should go. So it is somebody who handles the networking part. To proxy handles the networking part.
Mm-hmm.
And then worker container runtime in the sense the software responsible for running containers means it makes sure the Docker is running whatever container you're running. Know that. So that's what I say. No, to know Kubernetes, I should know Docker. Without Docker, Kubernetes is confusion for you. So what I'll do, don't worry. I know I really can understand what you might be feeling right now. So
Mm-hmm.
totally fine. Next class, I'll break down the structure with first Docker. I'll make sure I'll make you understand first Docker. Then we
Mm-hmm.
will go with the breakdown structure, what we studied in a diagram way with the multiple examples, where you have the concept for contain. What I can say. Okay, fine. Let's say mm, this is a ship. Okay, still not ship. Okay, I'll just draw it. Okay, and say let's say for a Docker, we have kind of image which I will draw. All these are containers. Mm. Like this,
Yeah.
many containers. Okay. So let's say if we go to the Google and see as well. So Docker logo, you can see this, right? So usually, huh. So usually this is Docker engine we call it as. Okay. On all these boxes are containers. Okay.
Mm-hmm.
How a ship containers will be there? Ship containers image. Okay. So let's say any ship you consider. Image. Okay,
Yeah.
fine. So how we have this all these containers, right? Like you
Yeah.
might have like right a few might like cold storage or room temperature like that.
Mm-hmm.
We have to make sure such that the product is not affected. If it is vegetables or fruits, something which carry from different countries, right? So they make sure it should be stored in the particular temperature, right? So as
Yeah.
that all this all the containers are isolated in its own place such that it should not be affected, right? So here how each container is isolated without affecting anybody else, right? So and everyone all are on the same ship, but different containers might contain different products, but everyone are in the same ship, right? The same
Yeah.
thing our Docker also does it. What does it do is it takes care of the things in such a way. All this is an application actually. Okay.
Mm-hmm.
भाई साहब, हाँ, all these are application actually. Okay, application in the sense this is a Docker engine which is running. Okay, and what is that also I'll explain you. And these are containers. Okay, containers means let's say one application is running here, one more application is running here. Like that, all these containers are applications. Okay, let's say if it is working same application
Hello, it's breaking up. I cannot hear you. Hello? Hello, can you hear me?
I'm so sorry, Raju. I don't know when did I drop. Tell me where did I drop first of all?
Um, you're saying about the ship and just in the initial time also that like within 2 minutes you dropped off.
Uh-huh. My God. Okay. No problem. This you understood, no? Here you were there?
Yeah, yeah,
Mm. Okay. Then this one Docker engine.
yeah, yeah. He's talking about that.
Mm. Okay. Then
Each application will be on different container. Yeah.
fine, I'll start from here. If you like with, then okay. It's good. Okay. But okay. Let's say example. Again, I'm repeating. There's a developer one. Okay. Developer one, and there's developer two. Okay.
Mm-hmm. Yeah.
One says, it's like I really put so much effort and finally my code is working, and is very much happy. But he says like he goes to developer two and see like see developer, I have already done it, so please please test it on your laptop as well. Then he says ki it's not working only on my laptop. How come you say it's working on your laptop? Then they might be like normal discussion like it's not working. They might be pissed off. He might be pissed off because he worked hard, right?
Mm-hmm.
So why? A number of reasons might be there. First reason might be a system issue. Okay, and the configuration, normal configuration, some dependency he might not support, or he might also downloaded some different versions, right? We have, right? So whatever we use and all versions matters a lot. Okay, if that
Yeah.
version is supporting very clear, it's not supporting, right? So a reason
Mm-hmm.
might be a number of things why it is not working, right? So that
Mm-hmm.
time we have another person, Docker says key, don't worry, I'm there for you. So he's like, Docker file will have all dependencies. Let's say to work on some of the program, they require 5 packages. Okay, might be
Mm-hmm.
anything. Have you have for Java? Java. Sorry, for Jenkins we require Java, right? So it supports in that way packages. Okay, so
Mm-hmm.
whatever it is, right? Because Jenkins before that we make sure Java is installed. If Java is not supported, then very clearly Jenkins is not working. So it is like base. It's important for us, right? The same thing here also, Docker file takes care how much packages you want. Tell me. And which version also you tell me. It takes care. Let's say you have something called Node.js 20 version. It won't. Okay. So it makes sure whatever Node.js like that, any of the dependencies which you're working for your application, right? It takes care of that. So all are packed in one file.
Sorry.
Packed.
Can I interrupt you? Sorry. Like,
Yeah, yeah, please.
yeah. Because all these packages should be in a Maven file or somewhere. We already have packaged everything in a WAR file or any kind of files. We have version and everything that should be in a WAR file. So, but the environment things like which Tomcat or what kind of server that should be configured or what in Docker file. Docker file is,
Mm.
for example, for I'm
Mm.
working on Java environment, like so
Mm.
usually I'm getting var files and the Maven file I specify all the dependencies, what version
Mm.
of
Mm.
Node.js or whatever the things required. So what's the
Mm.
difference on this?
Yeah, yeah. Okay, fine. See, let's say if you say, I'll consider Node.js because I'm not sure about Maven because I have not worked, but I can say Node.js. Okay. In Node.js, we have node modules, right? Where all the
Mhm,
dependencies are there. When you go npx, install or run whatever you give, it will give, and all the dependencies it will be installed. That is limited to Node.js only. Okay.
mhm,
Let's say with Node.js, I want some other I want a Nginx,
mhm.
then I want Apache. Okay. Like that, I want a MySQL example. I'm saying, okay, that's not this one compulsion.
Maybe
Example, I'm saying.
well, that kind of,
All
yeah.
these three, yeah, yeah, all these
It's
three
outside
together.
dependencies other than the project, maybe. Yeah.
Hmm.
Okay.
Exactly.
Yeah.
So not related to only that one. Apart from that also,
Okay.
all the packages and base packages with respect to this, whatever you want, the base dependencies also you can give here. Everything,
Mhm,
right?
mhm,
All in a packed. See, example, we have compass box, right? To write a geometry exam, we require compass protector, that's triangle scale, and divider, many things, right?
mhm,
Such that only like no matter everyone might pass the same compass and might do all the answers, write all the answers because they have that particular equipment. But let's say if he don't have the equipment, can he work? Can he write the exam? No, right? It works like a compass box for us where everything is packed in single box and it
mhm,
can be passed to different students, right? In the same way, here also what developer does, he no matter if he is working on Mac, he is working on Windows,
mhm,
and
mhm,
he is working on Linux. Okay, these are
mhm,
the three types of OS we know, right? So let's say these three people are working on different environment, like OS, right? All these three with a single Docker file it supports. And no matter whatever is your system configuration does not matter to it. Okay, if you have this single Docker file, it works same on everybody's laptop. This is one example. Another one is, let's say on
You're
our
saying
local
about sorry, you're saying about the Mac, Windows, Linux is a server where Docker is running, right?
yeah,
Okay.
means it works same on these environments.
Yeah, all
You
the
don't
environment.
Yeah,
It
yeah,
requires.
you no need to go and download the packages, support this version configuration. You no need to worry about it. It works
Okay.
same.
Yeah.
And let's say in local 3.7 is there. Okay, 3.7 version, you are working on some code. Okay, 3.7 नहीं बताते 9 3.9. Okay, uh, but same thing when it is going to production environment, right? It is working on 3.7. This is without Docker. I'm saying about. Okay, normal without Docker. This the question whichever I'm giving, right? It is without Docker. Okay, so what will happen? Of course, right? 3.9 it is supporting local, but on production it is supporting 3.7 means the output is really not correct. Okay, but same thing with the Docker, this problem is solved. If it is local 3.9, then it makes also sure on production also it is 3.9. Same. You're also same, they're also same. Everywhere same, such that your end product or your user should not get affected. Right? So this is how the Docker works like. Clear? Whatever I said till now
Yeah.
is about Docker.
Yes. Yeah.
Okay. Again,
Yeah.
this is Docker. Okay. And we have Docker engine. Okay. Docker engine means very, like I told, right? Okay. Now I'll tell. Docker engine is somebody who is the like base. It is a base where different application is running. Example, we have building, office building, right? We required a proper place, right? It's not like every day we are going to different office. Again, for sales team, it will be there because that is their work. They have to go to their clients and all. That's fine. But usually, a proper office, if you say any like Infosys or anything, Infosys building is fixed. They want a in one common place. They have different buildings, okay? But it is Infosys only. The same thing here also. Docker engine, who is the base? It's a base for them. It's a platform. On this, different buildings like different Dockers are different containers are running, right?
Yeah.
All might be he's working on, like, let's say for one might be finance department, another one might be HR department, admin department, then software department, okay, sales team, marketing, blah blah, different team we have, right? Each member has different buildings, right? Example,
Yeah.
I'm saying the same. Otherwise, based on projects, they might divide the building, okay, the same way, same common building but different containers, right? So
Yeah.
this is the Docker, how Docker works like, okay, fine. Why this much is important for us, how it is related to Kubernetes. That is a concept here. Okay. Let's say you have 5 members of team members. If you have 5 members, it's easy. You don't need to require for the team lead or manager. But if you have 500 people, then you definitely want team lead. Everything should be there in a compiled way such that everybody's work should be tracked. Everybody, should be everyone's work is distributed properly. There is no burden for somebody, and it should be tracked. To maintain the things, it should be tracked. Right? Lead will be there, then senior. Okay, lead will be there, and manager will be there. Again, lead, senior, manager. That is later part. That is not like we'll discuss later. Okay, means manager. To look after this 500 people, manager should be there. 5 people not required because 5 people can be adjusted. Okay, we can do it. 500 people not possible. The same way, to look after all these containers, it should be somebody who is leading them, and that leader is our Kubernetes
Okay.
leader, manager. I can say manager who takes care of all these containers, who will tell containers what you should do, and that person is our Kubernetes. So K8 is very much recommended for this. K8 takes care of all these containers. Let's say one container is coming down, something happened, application crashes, it's not working, or some reason might be there, but pod comes down, container is not running. So who takes care of this? Create is somebody who manages everything in different way. That's what we have called self-healing. We have auto scaling. Okay.
Mhm.
Self-healing, scaling, wrong click. Self-healing, we have self-healing in the sense if it is not feeling well, it makes sure it, brings up the other one without affecting the end user. Then we have auto scaling here. Okay. Auto
Mhm.
scaling in the sense, whenever your traffic is high, it will increase. Whenever
Mhm.
traffic is down, it will decrease. Okay. In that we have horizontal scaling and vertical scaling. Okay. We will
Yeah.
discuss that later. Then we have availabilities. It makes sure high availability is there. Means no matter what is your situation, your application is not affected with this problems, downtime and all. It will not happen. So like this, we have so many features of Kubernetes where it takes care of. So everyone are very much interested in Kubernetes because of these reasons. So you got it now. Why we will study Kubernetes?
Yeah.
Clear, right? Okay.
Yes. Yeah. Yeah.
Yeah. Now I will go with the introduction, setup. I'll give this example in your notes so that in case it would be helpful, no
Yeah.
rough
Sure.
notes.
Sure. Yeah. I need that.
Hmm. Docker also I have given. I'll explain that also in short so that you will have an idea. Hmm. Yeah, it's like that. Okay. Let's say hardware, which is our application. Then
Mhm.
operating system might be your Windows, Linux, or Mac. Okay. Upon
Mhm.
in operating system, our Docker engine will be there. You can see this now. Docker engine. Okay, this
Mhm.
is Docker engine. Actually, it is still starting. I don't know what happened to this. It should be started. Okay, it's running. Right. This is Docker engine, and I will tell you to support Kubernetes, we require Docker. Without Docker, Kubernetes will not work. Okay, why?
Mhm.
I'll tell you that. Mm. Then later, our container will have dependencies. All libraries, dependencies, tools, everything our container will have. This is only the container is about. The Docker works like. Okay. Example, each container, one single Docker engine with different containers. One, two, it might be three containers, four containers, any containers. Okay. Like that, if application one is running on 14 version, application two might be running on 16 version. But both are running on same common platform that is Docker. Is
Yeah.
right. So in this, it works like, and example, host machine, then comes your virtualization, then your two application runs on version 14 and 16 in this way. Okay. So like this, you have so many other terminologies in Docker. Docker architecture works for client, daemon, and registry. Registry is nothing but like kind of repo where public repos will be there, different contributors will be there, where we can also take that registry image and then we can work. Okay. Here in Docker image means application servers. Okay, it is like application only. Services, daemons, or applications. Image means that. We call it as image in Docker language. Okay.
Yeah. Image file is a configuration file, right? Other than that, what's the
Hmm.
registry? It's a
Huh?
different.
Sorry, I didn't get.
So you say there should be a Docker file that's
Hmm.
specifying all the configuration and everything, right?
Hmm.
That,
Hmm.
so which will be the part of the registry or
Docker image, no, registry is like already ready made. Let's say Nginx is there already pushed. That image will be final product will be on registry.
okay, okay,
Image thing that we should write. Docker file we should write. Okay.
okay.
And we will get from the documents. We have so many, so I'll tell you. And huh. So it works in this way. First comes client, then comes Docker, then comes your containers, runtime, then container, then runtime, then container is working. Okay. Like port example, 8080 is your common port, means parent port. 8081 is your child port, then 82, 83, 84. Like that, it works on different ports. It supports that. Okay, like it is distributed into different containers. We have room house in house. We have different rooms, right? So here also it works in that way. Hmm. So this is all about Docker. Okay, as I said, now bookish language. In 5 minutes I'll take for this, then we'll wind up. Okay. Docker is a
Mhm.
containers platform. A contain okay. Docker is called as containerization platform because it takes care of the containers. Okay. Kubernetes is called orchestration platform because it give an instructions to Docker. So it is called as orchestrations. I will tell
Mhm.
you that in some time. Hmm.
Yeah.
Here it does what? It allows you to package applications and dependency into lightweight portable containers. Okay, it helps developers build, shape, run application. It also makes consistently across environment, development, testing, and production. Right?
Mhm.
Why it is important? Why Docker? Because of portability means you can run on same on every system, like any system, might be laptop, your server, your cloud, anything, and it is lightweight compare because it shares the common host. I don't know one Docker engine, but or the many containers. So it is lightweight, and it is scalability means container can be scaled up or down is possible here, and consistency is there means it's working same on all the environment. Because of this, Docker is important. Okay,
Yeah.
key components of Docker are Docker engine, which is a core part of the Docker, runs same on every machine. Then Docker images means it takes okay. Docker images means it's kind of template. Okay, if you want to create a containers for Python, Node.js, MySQL, anything, all this considered as images. Okay, I'll show you here. Okay, explore. Hmm. You can see this, right? So many are there. Every day, actually, so many images will be uploaded to this. Okay, machine learning and AI related. That is PyTorch something. Okay, Tensor, Python. All these are images considered as images. Nginx. Okay, all this will be verified. Then only it will be uploaded, such that if somebody is using this, the security should not be breached. So all is taken care here, such that it should not be affected. Okay. And the same way, we have something call it as what MySQL, PostgreSQL. Okay, all these are like InfluxDB, Bash. All are considered as Docker images. If you want to explore, you want to search, you can go and search it, and you can get that things done. Yeah. Okay. So 10 days ago, 3 days ago, all these are images. All the applications, whatever supported, that is considered as images in Docker language. Okay,
What I
that's what.
understand, sorry,
Mm, mm.
the Docker images is, can you go to the previous slide? The
Right.
previous book. Ready only template used for to create Docker images. I thought that something Docker images is something we write to make our application work, right? But you say
Yes.
something about the Python instance or some other
Mm.
instance.
See, Docker image, no, Docker file, what we write. This is
Docker
here.
file we write. Docker image is Docker.
Uh,
Oh, yeah, okay.
ready made. Okay.
Images
Uh,
is
uh,
something.
this
Yeah.
is, yeah, no
Template.
problem. These are like that only. First time, no? So it
Okay.
gets like that only. Image means ready made, already there for you. Your
Oh,
example, no? Yeah, one here it is there, no?
this is
It's
specifically
ready.
for. Yeah.
Yeah, yes. This is ready for you. You can take it up whichever you want, right? This is ready
Mhm.
for you. But how to write, like let's say you want to customize your file, right?
Mhm.
So that time you go with Docker file, means a text file with instructions to build an image, like install library, copy code, set environment variables, anything if you want to write, that falls under Docker file.
Mhm.
Okay, you customize and you write it.
Yeah.
Okay.
Okay.
Again, we have containers, means we know, which is running on our Docker image. Means running instance of Docker images, multiple Docker images will be running on that common host, that is containers. Containers I told you, right? And hub is
Mhm.
like central repo to store and share your image. It's like a public repo. Everyone can store and do it. Okay. So in this way, it will be there. I think this is enough for now. Okay, to understand why we have one Kubernetes. Okay. So like this, if you want, you can explore. I gave few things, introduction part, so you can go through it. Okay. So this is all about Docker. And before this, history also. I think I should tell. History. It came in 2000. Like everything, application ran in physical server scaling and new hardware. Okay, early in 2000, virtualization came, which enabled multiple OS in one server, but remained heavy, very much heavy. Then next introduced something called a C group, but and namespace. Foundation of containers. Actually, because of this container topic came. Then in 2013, our Docker was introduced by Solomon Hykes. Then enterprises came into 2014 to 15. Docker Hub launched. On 2016 onwards, everyone started working on Docker. Actually, okay. Docker is like, we have one product by Docker, that is Docker Swarm. Okay. That Docker Swarm is also like, it will also work like Kubernetes only, right? But everyone don't want to go to Docker Swarm because they have some limitations of that. And the
Mhm.
Docker Swarm is only limited to Docker only because it's a Docker product, right? But
Mhm.
Kubernetes is not like that. Kubernetes supports everyone, right? And it has well advanced things than the Docker Swarm, right?
Mhm.
And before Docker, all were in physical service. Servers ran directly on hardware. There was no isolation. There was scaling required very much for new servers. And each app, one VM, one OS. It's slow. It was, startup was slow. Heavy resources were there. Deployment issues faced. It's like it's working on my machine. Problem complex, and setting up dependencies very much difficult. Okay. Okay, so these were the challenges before Docker, and in DevOps, it was very much difficult for us also, to work on different environment like dev, test, and production. Environment setup was slow and error was there. Scaling was not happening, right? And see, it was there, but it was